stars. This is the first set of notes for the second half of our astronomy unit. So your table of contents should just be labeled Astronomy Part 2, and then your types of stars notes would go on page 3. So let's go ahead and get started. So it turns out not all stars are the same, and we classify stars with by looking at a couple of different things about the star. And the first things that we look for is the color of the star. Alright, so these are ways to classify stars. Alright, you guys are going to take your own notes for this part. Own notes. Alright, so the color is going to tell you the temperature of the star. So the overall color of the star gives you a good idea of how hot it is, kind of going in order through the rainbow, red being the coolest relatively, like 2,000 to 3,000 degrees, whereas blue will be the hottest, anywhere from 11 to 28,000 degrees. And we see that our sun as a yellow star is pretty much right in the middle, 5,000 to 6,000 degrees. We can also look at size. All right, size is going to tell us a little bit about the star. All right, we can classify it by size. We can go anywhere from the sun, which is a pretty average, medium-sized star, but as you can see in this picture, there are plenty of stars that are a lot bigger than the sun. All right, so size is something we can look at as well. Right, but again, they're so far from Earth that they're going to be quite tiny when we look at them in the sky. We can also classify stars based on chemical composition. What's the star made of? All right, and we'll see in class that it's possible to actually figure out what chemicals a star is made of by looking at the light that it gives off. So the kind of overall color gives us an idea of the temperature, but if we use some scientific tools to kind of break that light down into specific colors and see how much of each color we're getting, we can get a pretty good idea of what the star is made of, which is pretty cool. And then the last way that we classify stars is based on their brightness or their magnitude. All right, magnitude is the more scientific term for this, so that's the term that we'll be using in class, but magnitude just means brightness. Apparent magnitude is how bright the star appears to be. So for someone on Earth looking up at the sky, apparent magnitude is, right, number 3 here would be the brightest star. But absolute magnitude is how bright the star actually is if we compare them all to each other, right? So apparent magnitude is going to depend not only on how bright the star really is, but also how far away it is. So when we know how far away a star is, we're able to calculate its absolute magnitude. And that's a better comparison because this way we're actually comparing the stars to each other. Lastly, we classify stars on this diagram that we call an HR diagram, all right, which stands for Hertzsprung-Russell diagram. All right, these are two astronomers who came up with this chart. They realized that stars, when they graphed their temperature and their brightness or their magnitude, the stars tended to form a pattern. All right, so an HR diagram is a chart of absolute brightness on the x-axis and surface temperature on the y-axis. So we've got absolute magnitude here, getting brighter as you go up. Negative numbers in magnitude mean brighter. You don't need to know that for the test. It's just a weird convention. Whereas surface temperature gets lower on this as we go to the right, which is a weird way to draw a graph, but that's the way the HR diagram is always drawn. I don't have a good reason why, but whenever you see an HR diagram, it's going to be drawn this way. And this allows us to classify stars and see how they change over time. So stars don't evenly occupy this space. There's a whole belt of stars in the middle. We call that the main sequence, and that's right where our sun is, right in the middle of that main sequence. Then we've got a section down here of what we call white dwarfs, right? Small, not so bright, but pretty hot stars. And then we've got a section of really bright yet really cool stars that we call red giants. And we'll look at this whole HR diagram thing more in class tomorrow, but it gives us a way to classify stars and see how they change over time. So kind of looking at this graph, kind of think to yourself, if you had a really bright yet kind of cool star, what section would that be in? What if you had a really bright star that was really hot? Or if you had a not so bright star that was pretty cool in temperature? And if you had a not so bright star that was pretty hot in temperature, think about what corners each one of those would be in. right? The one that's really bright and not so hot, right, would be in the top right corner. Really bright and really hot, top left corner with these blue stars. Not so bright, not so hot is going to be in the bottom corner with these red stars down here, and then not so bright but really hot is going to be down on the left corner. Alright, finish up your notes by writing 3 questions, and I will see you in class tomorrow to review this.